Welcome. This is Admin reporting live for Premier Magazine, live from ISC, but not live from Frankfurt. At the COVID-19 session, Peter Coveney from UCL explained about a very big project, a very big consortium that helped COVID-19. So if you look at the list of partners, it's quite impressive. It includes big centers in the US, big centers in Europe, and also projects like BioCompuMed, who are already developing software to support medical research. The problem, as Peter Coveney explained, is that you have to look for a kind of needle in a haystack. There are hundreds of millions of compounds that potentially could help, but most of them don't. So you're looking for, you don't know, very few things. Well, actually, you just hope that there's something. There is a traditional way of looking at compounds, whether they could be potential drugs that help for COVID. That is high throughput screening. That is a lab where you physically test things. It's automated, so it can go quite fast, but not so very fast. What they hope is that with virtual screening, that's what Peter Coveney told us, that with virtual screening they can do better and they can do it faster. What do they have to support? Well, basically they have the PZ8 as a supercomputer. That was until recently the fastest system in Europe. Then they have the SuperMUC NG, which was until recently the second fastest system in Europe. The Archer in Edinburgh, and several other systems that are having computing time available for this research. In the US, they have the Summit, until recently the fastest system in the world, the Frontera at TAC, and several other systems. So in total, it's quite an interesting amount of computing that is available to the consortium. What are they doing with it? Well, basically, there are now currently, what Peter Coveney told us, is that they have two types of techniques that they use. They use machine learning algorithms. Machine learning algorithms are relatively fast, but they heavily depend on the training data that you put in there. So with machine learning, the algorithm that you put in learns by doing. But if you don't give him the right training, it doesn't perform well. Molecular dynamics simulations are the other way. So actually with molecular dynamics, you are using the laws of physics to do the calculations, which cost much more computing power, but it's much more accurate than machine learning. So they combine it in a way where they do the first coarse screening with a machine learning algorithm called SMAX. And Peter Coveney told us that the molecular dynamics one is called TIES, so that does the more precise screening. The important is the quick turnaround time, so that you can do as much research as possible or support as much research as possible. If you want to get more details, go to the presentation from Peter Coveney, which is still available online on the ISC website. If you want to know more about what's happening at ISC, please stay tuned in to our channel. For Premier Magazine, this was Admin reporting.